Now, in this lecture and the next few lectures, I want to start talking about man-in-the-middle attacks. These are attacks that we can launch only if we are able to intercept the communication between two devices. Hence the name man-in-the-middle attacks. So, a normal communication would look like this, where the device is directly communicating with the entity that they want to communicate with. In a man-in-the-middle attack, the hacker would be able to place themselves in the middle of the connection, allowing them to intercept and see anything that is being transferred between the two devices. Now, there are a number of ways to achieve this. The first method that we'll cover in this course is using an ARP spoofing attack. ARP spoofing allows us to redirect the flow of packets, so instead of it flowing as shown in this diagram, it would flow through my own computer. So any requests sent and any responses received by the target computer will have to flow through the hacker computer. This means that any messages, any websites, any images, any usernames, any passwords entered by the target will have to flow through my computer. This allows me to read this information, modify it, or drop it. So as you can see, this is a very serious and very powerful attack. And the reason why it is possible is because ARP is not very secure. Now, for us to understand how this works, you need to have a basic understanding of what ARP is. ARP stands for Address Resolution Protocol, and it's a very simple protocol that allows us to link IP addresses to MAC addresses. So, for example, let's say we have a network here. We have devices A, B, C, and D. They're all connected to the same network. And we have the router here for this network. We can see that each device has an IP and a MAC address. And let's assume that device A needs to communicate with device C. Now we're also going to assume that device A knows the IP of device C, but as we know so far, in order for these devices to communicate within the same network, device A needs to know the MAC address of device C, because like we said before, the communication inside the network is carried out using the MAC address and not using the IP address. So this is a perfectly normal situation where we have a client that needs to know the MAC address of another client so that it can communicate with this client. So what this client does, it uses the ARP protocol. What do I mean by that? Basically, it sends a broadcast message. So it sends an ARP request to all the clients on the network saying, who has 10026? Now, all of these devices will ignore this packet except the one that has this IP address, which is 10026, which is device C. So all devices will not do anything, and the only device that will respond is device C, sending an ARP response. In this response, device C is going to say, I have 10026, my MAC address is this MAC address. This way, device A will have the MAC address of device C, and now it will be able to communicate with device C and do whatever task that it wanted to do initially. So all of this communication is facilitated using the ARP protocol. Like I said, the ARP protocol is a very simple protocol. As you can see, all it has is requests and responses. And the whole point of it is so that we can link IP addresses to MAC addresses or translate IP addresses to MAC addresses. So a device can send a request asking for a MAC address, and then the device that has the MAC address would respond with its MAC address. So each computer have an ARP table which links IP addresses on the same network to their MAC addresses. So if I go on the Kali machine and do ARP-A, you can see my ARP table here, and as you can see, it's linking the router's IP to the router's MAC address. Now same if I go to the Windows machine and run my CMD and do ARPA, you'll see again it's linking the router's IP to its MAC address. So this machine, anytime it needs to send any request to the internet, it will direct that request to this MAC address, to the MAC address that's associated with the IP of the router, which is 10.0.2.1. Now, this value in here can be easily modified by exploiting the ARP protocol. So let me go back to my diagrams. And right here we have a diagram of a typical network. And you can see that normally any device that's connected to the network, if it wants to send requests, it will send them to the router. The router will go and send that request to the internet, wait for the response, and then forward the response to the device that requested it. So if the hacker or the victim or any other computer on the network wanted to send a request, they will send that request directly to the router. Now what we can do is we can exploit the ARP protocol and send two ARP responses, one to the gateway and one to the victim. We're gonna tell the gateway that I am at the IP of the victim. So the access point will update its ARP table and it will associate the IP of the target with my MAC address. We'll do the same with the victim, so we'll send it an ARP response. We're gonna tell it that I am at 10.0.2.1. So it's going to update its ARP table and associate the IP of 10.0.2.1 with my own MAC address. So the result of this, the victim is gonna think that I am the router, and the router is gonna think that I am the victim. So anytime the victim wants to send any requests, the requests will have to flow through my computer, and I'm gonna forward them to the router. And then anytime the access point or the router wants to send responses, they're gonna go to my machine because it thinks that I am the victim, and then I'm going to forward it to the victim. So as you can see, this puts me in the middle of the connection and it gives me so much power, and we'll see all the things that we can do once we become the man in the middle. Now the main reason why we can do all of this is because ARP is not secure. Because first of all, clients can accept responses even if they did not send a request. So as I said before, we're gonna send a response to the access point and a response to the victim, telling them that I am at a specific IP, without them asking who am I, or without them asking for this IP. I'm just gonna send a response and they're gonna accept that response anyway. Not only that, but they're also not going to verify who I am. So when I say that I am at 10.0.2.7, I am clearly not at that IP because this computer is at this IP. But the access point will trust this and it'll actually update its ARP table based on the information that I send. Same goes to the victim. I'm gonna tell it that I am at 10.0.2.1. It's gonna trust and believe this, even though I am clearly not at this IP because the access point is at this IP. So these are the two main weaknesses with ARP protocol that allow us to run ARP spoofing attacks. Now that we know how ARP spoofing works, let's see how we can run this attack and redirect the flow of data so it flows through our device. This will allow us to intercept data and see everything sent to and from a target computer, including usernames, passwords, and so on. Now there are a number of tools that can be used to run an ARP spoofing attack. You can even build your own tool, and I cover this in my Python programming course. But in this lecture, I want to show you how to use a very simple yet reliable tool called ARP spoof. Then in the next lectures, we'll use a tool called BetterCap because it has more features. Basically, the main reason why I want to cover ARP spoof in this lecture, because it is a very simple tool, but it's very reliable. It's also ported to many operating systems, including iOS and Android. Therefore, if you learn how to use it here, you'll be able to use this tool on all of the other operating systems. So, you can only use this tool to redirect the flow of data and make it flow through your computer, and then you'll have to use another tool like a packet sniffer like Wireshark to analyze this data and do more stuff with it. And we'll cover all of this later on in the course. Now, using ARP spoof is very simple. First, we're gonna have to type its name, so it's ARP spoof. Then we're gonna do -I to specify the interface that is connected to the target network. And in my case, it's ETH0 because that's the interface that's connected to the network. So if I do ifconfig, you'll see ETH0 is the interface that's connected. Now, as you can see, I'm gonna be running this attack against my virtual NAT network. You can run this attack against any type of network, even Wi-Fi networks, and I will cover that later on in the course. But for now, just until you properly understand how this works, I highly recommend you do like I'm doing right now and test the attack against the virtual NAT network. So all you'll have to do is make sure the Kali machine and the target Windows machine are both configured to use the same NAT network. So we're gonna do -T to specify the target, and my target is at 10.0.2.7. As you can see in here, that's the IP of my target. And I'm gonna have to give it the IP of the gateway, which is at 10.0.2.1, as you can see in here. Now this will spoof the target, telling him that I am the router. We'll also need to run this command once more in here. So I'm gonna clear the screen, and again I'm gonna do ARP spoof IETH0, and the target this time is going to be 10.0.2.1 and 10.0.2.7. So right now we're gonna be telling the router that I am the victim. So the first one will fool the victim, the second one will fool the router. Now keep in mind, this attack will work against both Ethernet and Wi-Fi or wireless networks. I'm running it right now against the virtual network, which acts as an Ethernet or a wired network, but the attack can be executed exactly the same against wireless networks. All you have to do is connect a wireless adapter to the Kali machine, connect the adapter to the target network, and use it. So the same concept as the network scanner applies. You need to have a wireless adapter that works well with Kali, and you need to have that adapter connected to Kali and connected to the target network. So I'm gonna hit enter here, and I'm gonna hit enter here. And now if we go to the target machine and run the same command, ARPA, you're gonna see that the MAC address now for the router is different than what it was. And this is actually the MAC address of the Kali machine. So right now, this Windows machine thinks the router is at this MAC address, and every time it needs to send requests, it will send it to this MAC address, which means that they will be sent to this computer right here. Now, this computer is not a router, so when it gets requests, it's actually going to stop them from flowing and going to the router. This is a security feature in Linux. So you need to enable port forwarding so that this computer would allow packets to flow through it just like a router. Now to enable port forwarding, we're going to do echo 1 to proc sysnet IP version 4 IP forward. And as you can see, this command gets executed with no issues. And right now, this computer will still have its internet access, so we can go and browse any website we want. But all these requests are not going directly to the router, but they are going to this computer first, and then this computer is forwarding them to the router as shown in this diagram, and then when the responses come back, they're gonna go to the hacker first, and then they go to the victim. So, as you can see, a very simple tool. It allows us to redirect the flow of data so it flows through our computer, allowing us to become the man in the middle. And once we're the man in the middle, we can inject code in the browser of the target. We can steal usernames, passwords, see all the information that the person sends and receives, replace downloaded files with Trojans, and much more. Previously, we learned what ARP spoofing is and how to use it to intercept connections in our network using a tool called ARP spoof. I covered this tool because it is simple, reliable, and available for a number of operating systems. Therefore, learning how to use this tool can be useful in so many scenarios. However, in this lecture and in the next lectures, we're going to be using a tool called BetterCap. BetterCap can be used to do exactly what we did with ARP spoof. So we can use it to run an ARP spoofing attack to intercept connections. And it can be used to do so much more. So we can use it to capture data and analyze it and see usernames and passwords. We can use it to bypass HTTPS and potentially bypass HSTS. We can use it to do DNS spoofing, inject code in the loaded pages, and so much more. For now though, I'm going to show you how to install the tool and give you a quick overview on how to use it. And we'll go over all of that in the next lectures. So I'm gonna go to my Kali machine here, and to run BetterCap, all I have to do now is just type its name, BetterCap. Now, as usual, if you want to get more information on this command and how to use it, you can do --help, and this will give you a complete help menu. But you don't really need to worry about this now because we will be using the tool a lot throughout the course and you will learn a lot as you use it. So I'm going to clear the screen again. And to run the tool now, I'm going to type BetterCap, the name of the tool, followed by -iface to specify the interface that is connected to the network that I want to run the attacks against. And as you know, to get my interface, we can just do ifconfig. And I'm going to be running this against my NAT network, which is ETH0 is connected to. So I'm going to set my interface to ETH0. I'm going to close this. And I'm going to hit enter to run the tool. And as you can see now, we're inside the tool. We have a different prompt now in which we can use the commands of BetterCap. Now, as you can see here, it's telling us that we can type help to get a list of all of the commands that we can use with BetterCap. And since we don't know how to use it, I'm actually gonna type help. And perfect, as you can see, we get a full list of all of the commands that we can use. Again, I'm gonna use it with you now as we go through the course, so you can have a quick look on them, but don't worry too much about them. What's really important and you need to pay attention to right now is the modules. So these are all of the modules that we can use, or all of the things that we can get BetterCap to do. And as you can see right now, none of them is working except for the event stream, which is basically the module that runs in the background to handle all the events. Now, you can type help followed by the name of any module you want. And this will show you a help menu that shows you how to use this specific module. For example, I want to show you in this lecture the net.probe and the net.recon modules. So, since I don't know how to use them, I've typed help and I'm going to follow it by the name of the module, which is net.probe. I'm going to hit enter, and as you can see, you'll get a description of what this module does. So basically, it keeps sending UDP packets to discover devices on the same network, and we can do net probe on to turn on the module and net.probe off to turn it off. You can also see all the options that you can modify for this module, and I'm gonna talk about options and how to modify them in the next lecture. So for now, I'm gonna keep all these to the default option, and I'm just gonna do net.probe on to turn it on. And as you can see, this will automatically start discovering clients connected to the same network. So the 10027 right here is actually my Windows target machine. So if I go to the target Windows machine right here and do ipconfig, you'll see its IP address is 10027. So this is just another way of discovering connected clients quickly using BetterCap. And what you didn't notice right now is when we started the net.probe, it automatically started the net.recon. To confirm this, so if we go up right here, you can see the only module that was running is the events.stream. And now, if I do help, you'll see I actually have two modules running, the net.probe, which we just saw and we turned on manually, and the net.recon, which got turned on automatically by BetterCap. The reason for this is because the net.probe sends probe requests to all possible IPs, and then if we get a response, the net.recon will be the one detecting this response by monitoring my ARP cache and then adding all of these IPs in a nice list so we can target them. So now, because the net.recon is actually running, we can do net.show to see all of the connected clients. And as you can see, we get a nice list of all of the connected clients. We can see their IPs. We can see the corresponding MAC addresses for these clients. And it can also show you information right here about each one of these IPs. For example, it's telling us that this IP right here is the IP for ETH0. So this is the IP of this computer. It's also telling us that this IP right here is the gateway. This is the IP of the router. And you can also see at the vendor in here, it's attempting to discover the manufacturer of the hardware used in each of these clients. So as you can see for the gateway, it thinks that it uses a Realtek chipset. Now you can also see here the 10.0.2.7 device. Like I said, this is my target Windows device right here. So that's it for this lecture. I just wanted to give you a quick overview on how to get help about a specific module, how to run a specific module, and analyze the results that it returns. And in the next lecture, I'm going to show you how we can run an ARP spoofing attack using BetterCap to intercept the data and read usernames and passwords that flow through the network once we become the man in the middle, once we intercept the connection. Now, in this lecture, I want to show you how to run an ARP spoofing attack using BetterCap. This will allow us to place our computer in the middle of the connection and intercept data. Not only that, but we're also going to see how we can read this data so we can see all the URLs and all the websites that the target visits, and we'll see everything that they post. So anything, any usernames, any passwords they send to any websites, we're going to be able to capture them and see them. So first, we need to become the man in the middle, and we're going to do this using a module called ARP Spoof. So if I scroll up to the help menu, you can see we have a module here called ARP Spoof. So as usual, if we don't know how to use this module, we're going to do help arp.spoof because we want to see how to use this module and see all the options that we can set for it. So as you can see, as usual, we can do ARP spoof on to turn this module on. We can do arp.ban on, and this will literally just cut the connection of the target. This is very simple. You can try it on your own time. I'm not going to do it here. You can do ARP spoof off to turn it off, and arp.ban off to turn the ban off. Now, in the previous lecture, I also said anything you see under the parameters are the options that we can set for this specific module, but I didn't show you how to modify that. So in this lecture, we're actually going to be modifying some of these options. Now, as you can see, the tool is actually very helpful because first of all, it's giving us the option name in yellow here. So these are the options that we can set, that we can change. And then it's also telling us a description of what this option does and the default value. So for example, we can see we have an option called arp.spoof.fullduplex. You can see the description for this option, and basically what this option will do, if you set it to true, it will spoof both the router and the target. So it's similar to what we did with ARP spoof when we executed the command twice to spoof both the router and the target. So if you set this to true, both the router and the target will be spoofed and you will be in the middle of the connection. If you leave it to the default, which is false, you will only spoof the target machine. Now this can be useful if the router has some sort of protection against ARP spoofing attacks, because you won't be interacting with the router at all. But it's also limiting because we won't be able to do what I'm gonna do in the next lectures, because the router will communicate with the target device directly, so we won't be able to inject stuff in the responses that the router sends to the target device. Now I actually want to change this to true, and the method I'm gonna do this can be used to change any option in any module in BetterCap. So not only in the arp.spoof, if you're using any module, you can do help followed by the module name to get help about that module name. You can see all of the options that you can set in here. And then if you want to modify the value of any of these options, all you have to do is copy the option name, which is what I have right here, and type set followed by the option that you want to modify. And in my case, it's called arp.spoof.fullduplex, and I want to set this to true. So very, very simple. And like I said, you can use this command to change any option in any module in BetterCap. All you have to do is type set, followed by the option name, followed by the value that you want to set. So I'm going to hit enter, and that's done. If you don't see errors, that means it got executed properly. The next option that I want to change is the targets. So again, in the description, it's telling us that these are the targets that I want to run the attack against. And I can use a comma if I wanted to target more than one IP at the same time. So again, just like what I did before, I'm going to do set, followed by the option name, which is arp.spoof.targets. And you can actually use the tab to autocomplete. So if I just type TA tab, it will autocomplete the targets for me. And after this, I'm going to put the value that I want to set this option to, which is the IP of my target. And we can get this using NetDiscover, using ZenMap, or using the result that I got in here after I run the recon module. I did net.show, and we got all of this, which is the list of all of the computers connected to the same network. And my target right now is this particular device, the 10027. This is my Windows virtual machine right here. So I'm going to put the IP 10027. And again, we don't see any errors, which means that everything got executed as expected. Now we're ready to run the tool. And again, based on the help menu that we got, we can do ARP spoof on to turn this module on. So we're going to do arp.spoof on. And perfect. As you can see, we see no errors. It's telling us that the module is running. And if I do help, again, we're going to get a list of all of the modules that are running right now. And as you can see, we can see that ARP spoofing is on. Also, it is very important that you make sure that the net.probe and the net.recon are running. We did this in the previous lecture, that's why I didn't do it now. So right now, BetterCap should be doing what ARP spoofing was doing, fooling both the router and the target device and putting me in the middle of the connection as shown here. So let's go to the Windows machine right here, and I'm going to do ARPA. And as you can see, the router's MAC address right here is the same as the MAC address for this device, which is the 10.02.15. And if I go back here to the Kali machine and do ifconfig, you'll see this is the same MAC address as the MAC address of the Kali ETH0 interface. So basically what this means is this Windows machine, every time it wants to send something to the router, it'll send it to the Kali machine. And because we set the full duplex option on in BetterCap, the router also thinks that this Kali machine is the target machine. Therefore, anytime it needs to send a response to the Windows machine, it'll actually send it to BetterCap right here. And like I said before, this means every username, password, URL, anything the target computer sends or receives will have to go through the Kali machine, where we're going to be able to read it, modify it, or drop it. And I'm going to walk you through that in the next lectures. In the previous lecture, we learned how to use BetterCap to run an ARP spoofing attack and place ourselves in the middle of the connection between a computer and the access point. And every time I do this, I keep saying this means that all the requests and all the responses will flow through our computer, which means that we'll be able to see anything a user does on the internet. So we should be able to see the URLs, the images, the videos, the passwords they log in with, or anything they send or receive. So right now, we are already in the middle of the connection, and this data is already flowing through our computer. So all we have to do is just use a program to capture this data and analyze it. Now we can use Wireshark to do that, and I will cover this later on in the course, but for now, I'm going to use a really nice module that comes with BetterCap that will automatically capture all of this data, analyze it, and show me the interesting stuff. So all we have to do now is to tell BetterCap to capture all of the data that is flowing through this computer and analyze it for me. And to do this, we can use the net.sniff module. So you can do help followed by net.sniff to see all of the options that you can set for this module. But I showed you how to read options and change them. So for now, I actually want to run it without modifying any of the options. So I'm just going to do net.sniff on. So now everything that's going to flow through this computer will be captured and analyzed by the net.sniff module. So I'm going to close this terminal window and let's go to the target Windows computer. I'm going to open my web browser and we're going to generate some traffic and see if that's going to be captured by BetterCap. What we're doing right now will not work against HTTPS. But don't worry, we'll talk about how to bypass HTTPS later on and why this won't work. But for now, for testing, I'm just going to go to a website called VulnWeb. And I'm going to include its link in the resources of this lecture. So as you can see, this is a normal website that doesn't use HTTPS. It also has a number of links here. So if I click, for example, on this link, everything is loading fine, as you can see here. But if we go to the Kali machine, you'll see that every request that we sent was actually captured by this computer. So you can do this to any computer that is connected to the same network as you, whether it's a wired or a wireless network. So you can see there were requests sent to Google. If we scroll down, you'll see we made a request for this website, vulnweb.com. you can also see all of the other files that this website loaded. So you can see we have a logo loaded here. You can see we have a styles file being loaded here. Again, if there were more images, you'll actually see links to all of the images that are being loaded. You can see here, this is the second link that we clicked on, the testphp.vulnweb.com. So this is what we have right here in the top. Now also, let me just go back and maybe click on the first one. And as you can see, this is another website. It has a login functionality in here. And let's try, for example, log in with a username. Let's set the username to my name, Zaid Sabi. And let's put the password as 12345678990. I'm gonna click on log in. Again, as you can see, we got logged in, no issues at all. But if I go back to the Kali computer and scroll up, as you can see, we captured a login that was sent to this website, testhtml5.vulnweb.com. Again, this is exactly the website that we have here. And if you look in here, you can see that the username was Zaid Sabi and the password was 123 all the way up to 90. So basically the idea that I'm trying to get across right now, anything that the target computer sends or receives right now will be captured by the Kali machine. And like I said, we can do this to any computer or any phone that is connected to the same network as us, whether it's a Wi-Fi or a wired network. In the previous lectures, we learned how to use BetterCap to discover all clients on the same network, run an ARP spoofing attack to intercept the data, and then sniff data to see the usernames, passwords, and everything that's getting sent over the network. Now, in order to do this, we actually had to run a number of commands. So first of all, we had to do net.probe on to turn on the probe module. We had to set the settings for the ARP spoof module, turn that on, and then turn the sniffing module on. Now, every time you want to do this, every time you want to intercept data and see it on screen, you're going to have to do all of the steps that I showed you in the previous lecture. Or, if you're lazy like myself, you can use a caplet to do all of that automatically, which is exactly what I want to show you in this lecture. So, what do I mean by a caplet? Well, basically, a caplet is just a text file that contains all of the commands that you want to run. So, I'm going to resize this menu. I'm going to open a text file. And I'm just going to organize this a little bit to make it easier to follow. And I'm going to clear this window here. And I'm going to go to the first command that we had to run in order to do this. So again, scrolling up, the first thing we did was net.probe on. So in my text file here, I'm going to literally type this command, net.probe on. And as we saw, this will automatically start the net.recon module. Again, we enabled both of these modules in order to discover the connected clients and keep automatically discovering any new clients that connect to the network. The next thing that we did was modify the settings for the ARP spoof module. So we did set ARP spoof full duplex to true. I'm going to actually copy this and paste it here. Then we set the target IP. So again, I'm just going to copy this and paste it here. And keep in mind, this is very important. You want to make sure that you change the IP here to the IP of your target all the time. And if you are targeting multiple computers, you can just use the comma and type the next IP after the comma. Next, we turned on the ARP spoof module. So again, this is what I'm going to do here. I'm going to do ARP.spoof on. And finally, we also ran the sniffer by doing net.sniff_on. So again, I'm just gonna type this in here, net.sniff_on. So this is actually a nice summary of what we did in the previous lectures. Again, like I said, every time you want to intercept the connections, you're going to have to start BetterCap and run all of these commands manually. You want to start the probe module. You want to enable the full duplex, so you fool or spoof the target and the router. You want to set your target IP, and you want to turn on the spoof and turn on the sniff. So, to make this very easy, instead of having to type this every time we want to run an ARP spoofing attack and intercept data, I put all of this in a text file. I'm going to save this text file. I'm going to put it in my root directory, and I'm going to call it spoof.cap. So I'm going to save this now, and I can close it because we're done with it. And we can go back here. And what I'm actually going to do, I'm going to exit out of this. So I'm going to quit BetterCap, and I'm going to clear the screen. And if I do ls to list all of the files and directories in the current working directory, because right now I am in root. So if I do ls, you can see we have a new file called spoof.cap. And just to confirm, if I go down to my file manager right here, you can see we have a new file again in the root called spoof.cap. And all we want to do is feed this spoof file to BetterCap before we start BetterCap. Now, we don't know how to do this, so we're going to do BetterCap --help to see all of the options that we can set with BetterCap. And what we want to do is use the -caplet option right here. So we're going to run BetterCap like we used to do. First of all, we do BetterCap, followed by iFace to specify the interface that is connected to the target network. And in my case, this is ETH0. So far, this is identical to what I've been doing in the previous lectures. The only difference now is we're going to use the -caplet option to specify my caplet file that I just created. So I'm going to do -caplet, followed by the file that I just created, which is called spoof.cap, and that's it. Now, before I hit enter, just to confirm to you, I'm going to go back to my Windows machine, and I'm going to do ARPA just to show you. And as you can see right now, the router's IP right here has this MAC address. So after I run this, it should automatically start all of the modules that I just typed, and it should run an ARP spoofing attack. Therefore, the router's MAC address should change to the MAC address of ETH0 that is connected to Kali right here. So I'm going to hit enter. And as you can see, we actually got an error, and the error saying the caplet spoof could not be found. So I'm suspecting I made a spelling mistake, and I did. As you can see, I actually named the caplet soof, not spoof. So I actually make a lot of mistakes like this. So I'm just going to rename this to spoof, and we're going to go back here. I'm going to exit and run the same command again. And perfect, as you can see, we got no errors at all. If I do help, as you can see, automatically we have the spoof is running. We have the probe, the recon, and the sniff all running as soon as we ran BetterCap. If you remember, the first time we ran it, we only had the stream running, and we had to do everything manually and set the options manually. So this is a really, really nice way of doing it. Now, let's confirm that everything is working as expected. So I'm going to go to the Windows machine, and we're going to do ARPA again. And perfect, as you can see, the router's MAC address has changed to the same MAC address as the Kali machine, and the original router's MAC address, the correct one, was this. So this means that this Windows machine is now spoofed, thinking that the Kali machine is the router, and the router now thinks that the Kali machine is this machine. This will place Kali in the middle of the connection. And just to confirm this, just real quick, I'm already in VulnWeb. This is the website that we tested the login before. I'm actually even still logged in, so I'm gonna log out, log in again, and I'm gonna leave the username to admin, and I'm just gonna put a password again, 123490, enter. Let's go back, and perfect. As you can see, we wouldn't be able to get this if we were not in the middle of the connection. So the fact that we're getting all of this information means that we managed to intercept the data and see everything the target user sends or receives. And again, we have the username and the password right here. Like I said, this will only work with HTTP. We will discuss HTTPS in the next lectures. But in this lecture, I just wanted to show you an easy way of scripting the commands that you often run with BetterCap, because in the future, we're going to be doing a number of things that rely on us being the man in the middle. So, because I don't want to waste time enabling all of the modules that we're running here, so again, if I right click this and open with a normal text editor, all you'll have to do is just put your commands in a file, give a file a specific name, and then when you run BetterCap, all you have to do is just use the caplet argument followed by the name of your caplet file. Now, everything that we did so far will only work against HTTP pages. The reason why it works against HTTP because, as we've seen, the data in HTTP is sent as plain text, so it's text that humans like us can read and understand. That's why when we're the man in the middle, we're able to read this text, and if we wanted, we're able to modify this text as we wish. Now, this is obviously a problem, and this problem was fixed in HTTPS. So, as you know, most websites use HTTPS. The reason why, like I said, because it's a more secure version of HTTP, and basically the way it works is it adds an extra layer over HTTP, which is where the S comes from. So it's a secure HTTP protocol, and this extra layer will encrypt the plain text data that HTTP sends. So if a person manages to become the man in the middle, they will be able to read this data, but the data will be gibberish. It will not be readable to the person intercepting the connection. Now, HTTPS relies on TLS or SSL to encrypt the data, and this is very difficult to break. Therefore, in order to bypass this, the easiest method is to downgrade HTTPS connections to HTTP. So, since we're the man in the middle, we can check if the target is requesting a HTTPS website, and instead of giving him the HTTPS version of that website, we will give him the HTTP version. This way, the data will be sent in plain text and we'll be able to read it exactly as I showed you in the previous lecture. To do this, we'll have to manually configure and use a tool called SSL strip, and I show how to do this in my more advanced courses. But luckily, BetterCap has a caplet that does all of that for us. I also modified this caplet myself to get it to work more reliably and on more websites. So please make sure you use the custom Kali image that I made for this course because it comes with this modified caplet by default. If you want to use the original Kali, then you're gonna have to manually download this caplet and put it in the right path. I am using the custom Kali in here, so I won't need to do any of that. I can simply run BetterCap and use it. But before doing that, I just want to go to the home directory and modify the spoof caplet that we have been using in the previous lectures. And I just want to modify one thing in this. So I'm going to right click it and open it with LeafPad. And what I want to modify is I want to add an option to the sniff in here. So as you know, this line net.sniff on will turn on my sniffer, but before turning it on, I want to set the net.sniff.local to true. And what this option will do, it'll tell BetterCap to sniff all data even if it thinks this data is local data. The reason why I set this option to true, because once we use the HTTPS bypass caplet, the data will seem as if it's being sent from our computer. So BetterCap will think these passwords belong to me, to my computer, and it will not display it to me on screen. That's why we're setting it to true, so that we can see all the usernames and the passwords sent on the websites that we will downgrade from HTTPS to HTTP. So I'm going to save this, Control S, and quit it, Control Q. And now we are actually ready to go and use this caplet and see how we can downgrade HTTPS to HTTP and steal passwords from login pages that use HTTPS by default. So I'm going to go to my terminal and I'm going to use BetterCap exactly as I've been using it before. So we're doing BetterCap, the name of the program. We're giving it our interface after the iFace argument. We're using the caplet argument to specify a caplet to run as soon as we run the program. And we're running the spoof caplet, the one that we built in the previous lecture, that'll run the ARP spoofing command and run the sniffer for us. So I'm going to hit enter. And as you can see, everything got executed as expected. If we do help, we'll see all the running modules, and we have the ARP spoof and the sniffer running with the recon and with the probe. So this is exactly what we wanted from our caplet. So first of all, the HSTS bypass caplet is one of many caplets that BetterCap comes with. If you want to list all of these caplets, you can do caplets.show, and as you can see, you'll get a list of all of the caplets that you have and their location on the system. Now the caplet that we want to run is the HSTS hijack caplet, this one right here. And to run any of these caplets, all you have to do is literally just type its name. And as usual, you can use the tab to autocomplete. So to run our caplet right here, all I have to do is literally type HS and press tab. And as you can see, it will automatically autocomplete for me and type the caplet name. Now, if I hit enter, this will load the caplet with all of its options and it will run it for me. So as you can see, because we don't see any errors, this means everything got executed as expected. So let's go to the Windows machine, browse some HTTPS pages and see if we can sniff data, usernames, passwords, and URLs that they enter on their computer. So I have my Windows machine here. I have Chrome installed. This is the latest version of Chrome at the time of recording this lecture. A really good idea before trying all of these things is to remove your browsing data, because the websites that we're going to try to access might be cached and they might be just loaded from your cache. This will only happen if you're visiting the same website over and over again, mostly when testing. Therefore, it's a really good idea to Control-Shift-Delete and click on Clear Browsing Data. Make sure all of this is clicked. Make sure it's set to all the time and click on Clear to remove all of it. And let's go ahead and go to a website that uses HTTPS. So a good example would be linkedin.com. And perfect. If you look here at the top, you'll see the website is loading over HTTP, not over HTTPS. Therefore, we'll be able to see anything the user enters in these boxes. So let's put a username. Let's set it to zaid@zsecurity.org. And I'll put a password as 12345678890. It doesn't really matter. You can use any password. And I'm going to hit enter to log in. This is wrong, so obviously we're getting an error message. But if we go back to Kali, as you can see, we're capturing all of this data because it's not being sent over HTTPS anymore. It's being sent over HTTP. And if you look in here, you can see we captured login information. It's sent to linkedin.com, sent to this specific URL, a login URL. And you can see the username is zaid@zsecurity.org. And the password is 123 all the way up to 90. So that's really, really good. Let's go ahead and test another HTTPS website. Let's go to stackoverflow.com. Again, you can see on top, it's loading over HTTP, not HTTPS. So I'm going to click on login. And again, I'm going to put my email, zaid@zsecurity.org, and we'll put a password as 12345678990. Hit enter. And let's go to the Kali machine again. Scroll down this time because we're stuck on top. And perfect. You can see we have a post request in here. It's sent to this specific URL. Again, you can see login in the URL. You can see the website itself, stackoverflow.com. And if we scroll down a little bit more, we can see that the username is zaid@zsecurity.org. And the password, again, 123 all the way up to 90. So that is really, really good. Now we can downgrade any HTTPS connection to HTTP as long as the target website uses HTTPS, not HSTS. So this method will work against pretty much all websites that use HTTPS, except for the really popular websites such as Facebook, Twitter, and so on. So let me show you a quick example. If I go here and try to go to facebook.com, you'll see that the website got loaded over HTTPS, not over HTTP, even though we configured our couplet correctly, and even though we're able to downgrade HTTPS connections on a lot of websites such as LinkedIn and Stack Overflow. This is happening because Facebook is using HSTS, which is a little bit trickier to bypass. In the next lecture, we'll talk more about what HSTS is, why it's tricky to bypass, and how to partially bypass it and still get usernames and passwords from the websites that implement it, such as Facebook, Twitter, and so on. In the previous lecture, we've seen how to downgrade HTTPS websites to HTTP, and this allowed us to basically see anything a user does on these websites because data in HTTP is sent in plain text. Therefore, we were able to see the usernames, the passwords, the URLs, and anything they do on HTTPS websites. At the end of the lecture, I also showed you that the method will not work against Facebook, Twitter, and other websites that use HSTS. The reason why it won't work against these websites because modern web browsers come with a list of websites that they should only load over HTTPS. See, what we were doing in the previous lecture, whenever a browser requests a website, we load that website even if it uses HTTPS, but we always give him back the HTTP version. In HSTS, the browser knows that this website, for example, facebook.com, should always be loaded over HTTPS. So even before sending this request to us, it'll always send it in HTTPS, and it'll always only accept it if it comes back as HTTPS. So there's nothing we can do really once we become the man in the middle, because the browser is doing this check locally. It's checking this against a list that is stored on the computer itself. Therefore, the only practical solution at the moment to bypass HSTS is to make the browser think that it is loading another website. To do this, we're gonna replace all HSTS links in loaded pages to similar links, but they're not the same links. For example, we can replace facebook.com with facebook.corn. Now, I know this seems very suspicious, but trust me, when it goes into the URL bar, the RN here at the middle, it'll seem very similar to the M letter. Another way of doing this, you can replace twitter.com with twitter.com, but with a single T here instead of a double T. I know this sounds a little bit confusing right now, but let me go and do it practically and you will see how this is gonna work. So right here I have my Kali machine and we're actually gonna use the HSTS caplet that we used in the previous lecture. As mentioned in the previous lecture, this caplet is already installed in the custom Kali. If you want to use it with the original Kali, you'll have to manually download it and place it in the right path in user, local, share, bettercap, caplets. I have the caplet right here. Like I said, this is already the correct one because I am using the custom Kali. If we go inside it, we have a file called hstshijack.cap. This is the configuration file of the caplet. So I'm going to right click it. I'm going to open it with other application. I'm going to click on view all applications and you want to pick any text editor that you have. So I'm going to keep this at LeafPad. You might have to scroll down to find it, but I have it here. I'm going to select. And as you can see, we have a normal text file with all the configurations that we can set. And I've already pre-configured this for you. The main things that you want to understand and maybe change is the targets and the replacements. So the targets are the domains that use HSTS that you want to replace. For example, I have twitter.com in here, and I also have star.twitter.com. Basically, when you use a star, this is a wildcard, and it basically means any subdomain .twitter.com is a target as well. In the replacement, you want to tell the program what to replace this target with. For example, whenever we see twitter.com, we're going to replace it with twitter.corn. Similar goes for Facebook and Apple and a few other domains that I set. You can also play around with the obfuscate and encode options. I've set both of these to false because basically what these will do, they'll obfuscate the code and encode it. But I noticed some browsers like Firefox will block obfuscated or encoded code. That's why I set both of these to false so that the code is left as is. Here in the payloads, you can set any other JavaScript code that you want to inject. Leave this the same. We'll talk about JavaScript injection in a future lecture. Finally, you want to make sure that the DNS spoof domains are set exactly the same as the replacements in here. So I literally copy this line and paste it here. Now I'm actually going to keep all of this the same. I don't need to modify any of it. But like I said, if you're targeting different websites or if you want to use different replacements, for example, if you wanted to use a Twitter with a single T and keep this .com, you can do that here. If you wanted to use a Facebook with a single O and keep this .com again instead of .corn, you can do it here. Once done, make sure you save and quit this file. And we're ready to run the attack. So running this attack is actually going to be identical to what we did in the previous lecture. You just want to make sure you modify this file properly. So going back to bettercap, I'm going to clear the screen, run bettercap with the same command, loading the spoof caplet so we can do all of the ARP spoofing commands and run the sniffer all automatically. And perfect, as you can see, everything is running as expected with no errors. If you run this and you get an error, just do exit and run bettercap again. Next, we want to run the caplet, the HSTS hijack caplet, exactly as shown in the previous lecture. All we have to do is type HS tab, it'll autocomplete for us, and hit enter to run it. Again, as you can see, no errors, so everything is working as expected. Let's go to the target machine and see how this is going to work. So I have my Windows machine right here. This is Chrome, the latest version in April 2019. And before I do anything, like I said, it's a good idea to always just remove the browsing data. And before I actually load any websites, it is very important to understand that even with everything that we're doing right now, if you try to go to Facebook and type .com at the end here, it will not work. What we're doing right now will not work because Chrome right here has a list that is stored on this computer that says do not load facebook.com unless it is loaded over HTTPS. So if you type Facebook right here like this, it will not work. The only way we can do this is if the user first goes to a search engine, for example, google.ie for Ireland. And then in Google, as you can see, Google doesn't use HSTS, so we bypass this using the normal HTTPS bypass. And then if the user in here searches for their target website, for example, Facebook, then our script is going to run in the background and it's going to replace all links in this page for facebook.com with facebook.corn. So if I actually hover over this, you'll see in the status bar, the website that will be loaded is facebook.corn, not facebook.com. This is fine here. It still says facebook.com, but only in the code of the HTML page, facebook.com got replaced with facebook.corn. So if I click on this link, again, as you can see, we get a normal Facebook page. But if you look here on top, you'll see there is no HTTPS. And if you look at the domain name, you'll see it says .corn, not .com. Again, like I said, you can actually keep this .com and use Facebook with one O, or you can add an extra O. You can be as creative as you want with this. This is just an example that I'm giving you. Now, once we're here, we can log in normally with my username, so zaid@zsecurity.org, and put my password 1234567890. Hit enter, and if we go back, scroll up. Perfect. As you can see, we have the username zaid@zsecurity.org and the password all the way up to 90. Now, like I said, the only way for this to work is if the user gets to Facebook through another website that does not use HSTS. If they go on the URL bar and type facebook.com themselves, we will not be able to do this. That's why this is considered as a partial solution and not a full solution. In the previous lectures, we covered how to sniff and read data from HTTP, HTTPS, and preloaded HSTS websites. We spoke about the limitations of each of these cases, but we did that as we are going through the lectures. Therefore, I feel like some of the details might be missing, and therefore I made this table right here, and I'm going to show you some examples in this lecture just to lay everything down for you so you understand exactly how this is going to work and what are the limitations. So first of all, we spoke about HTTP websites, and an example of this would be a website that doesn't use HTTPS, just loads over plain HTTP, similar to vulnweb.com. Then we spoke about HTTPS websites, and this would cover most websites on the internet. So examples would be linkedin.com, WinZip, Stack Overflow, Google, the local Google, so not google.com, but the google.ie or .co.uk or .in, any local Google domain, and netflix.com. Now the list here could go on for very long because, like I said, most websites use HTTPS. And finally, we spoke about the most restrictive and the most secure method of communication, which is preloaded HSTS websites. And the way this works, we said the web browser itself will have a list of hard-coded websites that will only load over HTTPS. And therefore, because the browser has to contain this list locally, it will not contain all websites on the internet. It only contains very popular websites, such as Twitter, Facebook, and GitHub, and so on. Now, we could have a bigger list in here, but it won't be as big as HTTPS websites, as most websites use HTTPS. Now, when it comes to HTTP, no encryption is used, so there's nothing you need to do to bypass. So you can basically use the basic BetterCap, no modifications at all, and it works perfectly with Firefox and Chrome, so you'll be able to read the data and even modify it, as we're going to show you later on in the course. Then when it comes to HTTPS and HSTS, we can't decrypt HTTPS, and therefore what we try to do is we try to downgrade HTTPS to HTTP, and then when the website is loading over HTTP, we will be able to read all of the data that is being sent and received, so we'll be able to see the usernames and the passwords and so on, and as I'm going to show you later on in the course, you'll be able to modify this data. So you'll be able to launch attacks like DNS spoofing, where we redirect the domain to another location or inject code in the loaded website, but all of that is dependent on loading the website in HTTP. Therefore, when it comes to HTTPS and HSTS, the goal is always to downgrade that website or downgrade that connection to HTTP. So for this to work, we used a custom modified Kali that comes with the latest version of BetterCap and a modified HSTS hijack caplet. This is the caplet that downgrades HTTP to HTTPS. And this works perfectly with the latest version of Firefox. So let me show you a quick example. We're going to load BetterCap with the HSTS hijack caplet and then try to load some of these websites. And the goal is that these websites should load in HTTP, not HTTPS. If that happens, that means we can read all of the data and analyze it, and we can even modify it, as I'm going to show you later on in the course. So right here in my Kali machine, I'm just going to start BetterCap exactly the same way as we usually do. I'm selecting my interface and my spoof caplet. And then I'm going to start the HSTS hijack caplet by typing HS tab, and it will auto-complete for me. I'm going to hit enter, and now it's working. And let's go to the Windows machine. And as you can see, it's telling me that I'm using the latest version of Firefox. And let's go ahead. Before we test, I'm just going to remove all browsing data. So I'm going to press Ctrl, Alt, and Delete. And we're going to tick everything, make sure everything is selected in here, and click on OK. And let's go ahead to the first HTTPS website like linkedin.com. And perfect, as you can see, the website is loading over HTTP, not HTTPS, because we can see this cross over the lock. But most people won't notice this, and basically, like I said, that means we can read whatever username and password the user will put in here, and we can modify the data and inject data in this, and you'll see this later on in the course. Now, I'm not gonna log in now because we've already seen this. The goal now is just to show you which websites are gonna downgrade to HTTP. And even if you don't see the login data now, if I log in and you don't see it in BetterCap, that is completely fine because the sniffer that comes with BetterCap is not perfect. I will show you better sniffers later on in the course. So the main goal when we're using BetterCap is to be able to downgrade HTTPS to HTTP. So let's load another HTTPS website like stackoverflow.com. And perfect, as you can see, it's downgrading as well. And let's do a last one now. Let's go to netflix.com. And again, perfect, it's downgrading, it's loading over normal HTTP. So we haven't done anything different from what we covered earlier. Everything is working perfectly with Firefox. Now, when it comes to Chrome, there is a slight modification that we'll need to talk about. So let's continue testing with Firefox. So moving on to preloaded HSTS websites similar to Twitter, Facebook, and GitHub. Again, for this to work, we're going to have to use the custom Kali with BetterCap with the custom HSTS hijack caplet. Now, let's go ahead and test it with Firefox. So the way this will work, as mentioned in the HSTS bypass lecture, the target will first have to load a normal HTTPS website. An example would be a local Google domain, for example, google.ie or google.in or google.co.uk, anything but the google.com, because these use normal HTTPS, and therefore we will be able to downgrade them to normal HTTP, as you can see in here. And then once they are on any website or any search engine that uses normal HTTPS and we successfully manage to downgrade it to HTTP, if they search for a HSTS website, for example Twitter, the HSTS hijack caplet is going to replace the link for twitter.com with twitter.corn. Therefore, that will bypass the hard-coded list that the browser comes with, because it does not have an entry for a website that is called twitter.corn. So if I hover my mouse over here, you can notice at the bottom the website that we will go to is twitter.corn and not twitter.com. Now this replacement takes a second or two, so if you hover over it straight away as soon as the website loads, you might actually notice twitter.com, and then instantly it's going to change to .corn. Once it changes, if the user opens this, you're actually going to get a redirect notice like this one that will not work automatically. So this is another limitation with this method. But if the user actually goes ahead and loads the website, you will notice that we will get a website that is identical to Twitter, which we can use to sign in or sign up, but the website is loading over normal HTTP, not HTTPS. And if you note, it's twitter.corn, not .com. So if the user looks in here, they might be able to notice that something is fishy happening, but I would say it'll pass most users. So now that the website is loading over normal HTTP, you can first of all read the data the user sends, for example, usernames and passwords, and you'll also be able to manipulate this page and inject evil code in it. And we will cover that later on in the course. Let's have another example. So let's close these and let's go ahead and look for Facebook. Again, Facebook is another example of a website that uses HSTS. If we hover over it, you can see already it's being replaced to facebook.corn. So let's open it in a new tab and open it again. And perfect. As you can see, Facebook loads normally over HTTP and not HSTS or HTTPS. Again, once the user logs in, you're going to be able to capture the username and the password, and you'll be able to manipulate this page. So that's everything for Firefox. HTTP obviously works with no issues at all. HTTPS also works with no issues at all. And HSTS, you just need to make sure that the target websites are listed in the HSTS hijack caplet. And I showed that in the HSTS hijack lecture. So if you don't know how to do that, please revise that. But as you can see, it's working exactly as expected, as long as the target user accesses the HSTS website through a normal HTTPS website. Now, in the next lecture, we'll have a quick recap for Chrome, because Chrome is slightly different and could be slightly trickier. So that's Firefox covered. Let's go ahead and take a look at Chrome. Now, again, for HTTP, as we mentioned, everything works as expected. It's a very simple scenario. For HTTPS, you still want to use the same configuration as Firefox. So we're going to use the custom Kali, which comes with the latest better cap and a custom HSTS hijack caplet. Everything will work as expected in this case. The only thing is you need to make sure that you input the target website in the HSTS hijack caplet. So similar to what we did with HSTS websites, you're actually going to have to include all of the HTTPS websites that you want to target and you want to downgrade to HTTP in your HSTS hijack caplet. So it's a bit of a limitation, but that's the only way we can do it with the latest version of Chrome. For example, we have Netflix. So as we know, Netflix worked perfectly fine in here. So let me just go quickly on Firefox, netflix.com. And as you can see, it's loading perfectly fine. Now, if I load that now on Chrome with the exact same configuration of BetterCap, as you know, it's already running, it's going to load over HTTPS and not HTTP. The only way around this is to actually go back to my Kali machine, open up my file manager, and open up the HSTS hijack caplet. So you can do Control L to do that, or you could press in here and press a // and it's stored in USR, local, share, bettercap, caplets, HSTS hijack. And the caplet that we want to modify is HSTS hijack.cap. So it's this caplet right here. We're going to right click it and open it with another application, view all, and open it with my LeafPad with the text editor. So I showed you how to do all of this in the HSTS bypass lecture. That's why I'm doing it fast. Please revise if you don't remember. And what you need to do is simply in here, input the HTTPS websites that you want to downgrade to HTTP. So in this example, we want to downgrade netflix.com. So we're going to input it in here, and I'm going to select it again. And I'm actually going to put it in the next row and the replacements as well. And finally, we're going to put it in the DNS spoof. We're going to save, quit, and we're going to go up and run bettercap again. So I'm going to exit, clear the screen, run bettercap with the spoof caplet, and then run the HSTS hijack caplet. And let's go ahead and test this with Chrome. So before testing, it's always a good idea to remove all browsing data. So Control-Shift-Delete, make sure all time is selected, and make sure you tick all of the boxes. We're going to clear. And let's go ahead and go to netflix.com. Hit enter. And perfect. As you can see, Netflix is loading over normal HTTP now. So again, if you're inputting any username and passwords in here, you'll be able to capture them. And you'll be able to modify this website and the requests on the fly because everything is sent over HTTP, which does not use any encryption. And we will cover that later on in the course. So the main idea is all you have to do is simply add the websites that you want to downgrade to HTTP in your HSTS hijack caplet. So that's HTTPS for Chrome done. Let's go ahead and take a look at preloaded HSTS websites on Chrome. This will work exactly the same as Firefox. So you're going to need to use the custom Kali with the bettercap with the custom HSTS hijack caplet. And similar to what we did with Firefox, the targets will have to be in the HSTS hijack caplet. So we're not doing anything out of the ordinary. The only thing is secure DNS needs to be disabled. So secure DNS is a setting that Chrome has. And if it is enabled, the web browser is going to use encryption when it's making DNS requests, and therefore it'll render our attack right here with the custom HSTS hijack caplet useless. Now, the good thing is secure DNS is not always enabled by default. It depends on the country of the target. For example, in Ireland, if you download the latest Chrome web browser, it's actually going to come with secure DNS enabled, and therefore the attack is not going to work unless it is disabled. So if your target is in a country where secure DNS is not enabled by default, chances are they don't even know about this option, and it's probably going to be disabled, and therefore the attack will work. So let me show you where this setting is. In my Chrome, if we go to settings, and we can use the search icon in here to search for that setting, and we want to search for secure DNS. And as you can see, it's telling us it's in the security settings. And if we scroll down, you will notice that use secure DNS is enabled. So if I just turn this off and close this window, and let's go ahead and test the attack exactly the same way that we tested it before. So we're going to go to a local Google domain, for example, google.ie. As you can see, it's loading as normal HTTP, not HTTPS. Therefore, the HSTS hijack caplet is going to be able to modify this page, play with it, and change the links to .corn. And let's look for Twitter. And again, if we hover here over the link, you'll notice at the bottom it's twitter.com now, but literally within a second, it's going to go back to being twitter.corn. Let's open it in a new tab. And perfect, as you can see, Twitter is loading over normal HTTP. And again, now if the user logs in, we will capture everything, or because the website is loading over normal HTTP, we're going to be able to inject anything that we want and modify the website and inject evil code in it. And I'm going to show you how to do all of that later on. Now in this lecture, we're going to learn what DNS spoofing is and how to perform it. DNS is a server that converts domain names such as google.com to the IP of the server that is hosting this website. So when you type google.com in your web browser, the request goes to a DNS server. The server responds with the IP where google.com files are stored, and the browser will load the website from this IP. Now, when we are the man in the middle, the request for google.com will pass to us first before it goes to the DNS server. Therefore, instead of giving the IP of the server that is hosting google.com, we can actually give any IP we want. So we can redirect them to a fake website with a backdoor or with evil code, hijack software updates, and so much more. We'll actually have examples on this in future lectures, but for now, let's see how we can run a basic DNS spoofing attack in which we redirect requests from a specific website to our own website or our own web server. Now, before we run BetterCap, let's decide on where to redirect our target to. So we can redirect them to any website we want. For example, when someone requests google.com, we can redirect them to Yahoo. But what I want to do is I want to redirect them to my own website, to a local website that I'm going to start on Kali. So Kali comes with its own web server, so we can actually use it as a website. And to do this, all we have to do is just start the web server. So we're going to do service Apache 2 start. So Apache 2 is the name of the web server, and we're saying that we want to start the service. If I hit enter, we see no errors, which means that the server is working now. And to access this website, to access this server, we have to go to Kali's IP. So as you know, to get our IP, we can do ifconfig, and we can see our IP is 10.02.15. So if I just go to a web browser and go to 10.02.15, you'll see I'll get the default page of this website. Now the pages for this default website is stored in var www HTML. So I'm going to open my file manager and I'm going to click here on the title bar, press / to open it, and we're going to go to var www HTML. And as you can see, these are the files for this website. So if you want to install a fake website or any type of website, all you have to do is just put its files in here. Now, index.html is the file that gets loaded here by default. So this is what you see in here. So I'm actually going to right click it. I'm going to open it with another application. I'm going to select my text editor, and this will open the HTML code for me. And I'm actually just going to remove this, and I'll just put a smiley face. Like I said, we're just doing this for testing, so just showing you which files get loaded by default and where you can actually put a website if you wanted to host a proper website here. So I'm going to go back here, and if I refresh the page, you can see we get the smiley face in here. Now that's perfect. Right now we still haven't executed our DNS spoofing attack, but what I want to do is when my target tries to go to a specific website, I'm going to redirect them to this page that shows this smiley face. So let's go to the target machine first, and let's go to our target website. I'm going to do this against my own website, zsecurity.org. So if you load this website, you'll see we'll get an actual security website with a number of topics and all that kind of stuff. Basically, the website is working as expected. Now, let's go ahead and run this attack. So I'm going to go to BetterCap. I'm going to run it using the exact same command that we've been using so far. So we're just doing BetterCap with the interface, with the spoof caplet, so we can intercept data and modify it as it's flowing through our computer. And as you can see, it's running with no errors, so that's all good. Now, the module that we want to use is called DNS spoof. So if I do help right now, you can see it right here. It's called DNS spoof and it's not running. And as usual, if we don't know how to use a module, all we have to do is do help followed by the module name. And in this case, it's DNS spoof. And as you can see, we get all the options that we can set for this module. First option being the DNS spoof address. This is the address that the user will be redirected to. So if you want to redirect them to another website, you have to put the IP of this other website here. In my case, I want to redirect them to my local website, to the website that we have here, which is running at 10.02.15. Therefore, I'm not going to have to modify this because by default, this is set to the IP of my interface. The next thing that we want to modify is the dns.spoof.all. We want to set this to true so that BetterCap responds to any DNS request. So, just like any other option within BetterCap, to change its value, we have to do set, followed by the option name that we want to modify, and in this case it's dns.spoof.all, and we want to set this to true. Sorry, this is all being produced by the sniffer. The next option that we want to set is the dns.spoof.domains. This will specify the domains that we want to target, that we want to spoof. And as mentioned, we can use a comma to separate more than one domain. And as you know, we want to target zsecurity.org and we want to redirect that to our own website running on Kali. So we need to change this option right here, dns.spoof.domains. And again, we're going to do this by doing set, the option name, which is dns.spoof.domains. And we're going to set this to zsecurity.org. As mentioned in the option, we can use the comma to specify more than one domain. And the other domain that I want to specify is star.zsecurity.org. So the star right here is a wildcard, and it basically means that I want to target any subdomain .zsecurity.org. So I'm going to hit enter and we don't see any errors. So everything is set as expected. And all we need to do now is start the DNS spoof. And to do this, we just need to run dns.spoof on exactly the same way that we start any other module. I'm going to hit enter. And this should be running right now. And as you can see, it's telling us that it's going to spoof zsecurity.org to this IP, which is again, this is our IP. We verified this using the ifconfig command. And keep in mind, we actually did not have to give BetterCap this IP. It got it automatically. It's also telling us that the other target is star.zsecurity.org and it'll be spoofed to this. Now, let's go to the target machine and test this. And before you test this, please keep in mind, you might need to wait for a minute or two for the changes to propagate. Also, if you just loaded this website, just like I did right now, it's a good idea to remove all your browsing data. You won't have to do this in real life scenarios, unless the target person is constantly loading the same page, which doesn't happen a lot. But if the target person goes ahead and browses a few websites, comes back to zsecurity.org, and perfect, as you can see, we got redirected to the smiley face instead of loading zsecurity.org. Now this will work against all websites, even if they use HTTPS. As you saw earlier, zsecurity uses HTTPS and it loaded over HTTPS by default. The only websites that this will not work against are websites that use HSTS because, again, as I mentioned before, the browser has a list of these websites. The list is stored locally on the target computer, so it doesn't send any requests, and it'll only load these websites over HTTPS. So even though the attack will work, the browser will refuse to load the website that we are spoofing them to. Now, as you can see, what we did so far is not very useful. All we did is we showed a smiley face. But DNS spoofing is very, very useful in so many scenarios. You can use it, for example, when someone is trying to go to a login page and show them a fake page, or if they're trying to go to Z Security, for example, and then just show them another Z Security website with some malware embedded into it. You can also use it to serve fake updates. So whenever they have a software that's going to check for updates, we can DNS spoof that request and send them a fake update with a backdoor, and we'll see that later on in the course. So it's a really, really handy skill that can be used in so many scenarios. So far, we saw a number of things that we can do once we become the man in the middle. So we saw how we can see anything a target computer does on the network. So we were able to see the websites, the usernames, the passwords, the images, anything they load on their browser. We also saw that since we're the man in the middle, we're able to redirect them to other websites. So whenever they request a domain, we can redirect them to somewhere else by doing a DNS spoofing attack. Another really cool thing that we can do is modify the HTML, modify the pages as they load on the target browser. Obviously, this is all possible because we are the man in the middle, because we're able to intercept all this data. So we can wait for the HTML code, which is the code that's responsible for loading web pages. And as it flows through our computer, we can insert any piece of code that we want, and the browser will execute this code. Now, HTML is only responsible for rendering the elements that you see on the web page. So it's responsible for the buttons, for the forms, for the text. It doesn't really allow us to do much. But modern browsers can execute JavaScript code. JavaScript is a powerful programming language that we can use to do so many things. We can actually modify the whole page, remove elements or add elements into the page. We can replace links, and this is actually what I did when I modified the HSTS plugin. So I added code that will replace the HTTPS with HTTP, and I also added code that will replace the actual link, the actual domain name, with the spoofed domain name, with the one with the .corn, or to whatever you set it to in the script. You can even use it to hook the browser to other browser exploitation frameworks, which we can use to further exploit the target and even gain full control over their computer. And we'll see that later on in the course. But for now, I'm going to show you how to inject a very simple JavaScript code into the loaded pages, and then we'll build up on that in future lectures and see how powerful and useful this can be. So, right here, I have my Kali machine. And before I run Bettercap and show you how to inject JavaScript, first of all, we need to have some JavaScript code to inject into the target browser. So I'm going to open a text editor, and I'm going to write a very, very simple JavaScript code. Like I said, we will see how we can use this to run more useful codes, but for now, we're keeping this simple just to see how we can actually run JavaScript code. So all I'm going to do is alert, open a bracket, quotation mark, and I'm going to say JavaScript test. I'm going to close the quotation mark and close the bracket and add a semicolon. So right here, this code, all it's going to do is it's going to display a warning message, an alert message saying JavaScript code. So since we're going to try to inject this code into all pages, every time we load a web page, we should see a message saying JavaScript test. Now I'm going to save this. So I'm going to go to File, Save, and I'm going to put this in my root directory, and I'm just going to call it alert alert.js. I'm going to hit enter, and that is saved now in my root. So if I quit it, we can see we have the file right here. So this is the file that contains the code that we want to inject into any web page that loads on the target computer. The next step is to go to our HSTS hijack plugin. So as I showed you before, this was in user, local, share, better cap, caplets, HSTS hijack. Make sure you use the one that I included in the resources, not the one that comes built in with BetterCap, because the built-in one will not work as you want it. So in here we have the HSTS hijack.cap file. This is the configuration file for the whole plugin. So I'm going to right click this and open it with my text editor. And in here, what we want to modify is the payloads right here. So as you can see in here, it's already injecting a JavaScript file called keylogger.js, but we also want to inject our own code. So I'm going to add a comma here, and I'm going to add star followed by a colon. We added this star right here to say that I want to inject my script into any page that the target loads. If you want to inject your code into specific domains, then you can remove the star and just list the domains that you want to inject this code in right here. But like I said, we want to inject this into all pages, so I'm going to put this as a star, and after the colon, I'm going to put the location of the JavaScript file that I want to inject into the browser. So if we look back in here, this is the file that we just created, which is in root in my home, and it's called alert.js. So I'm going to put in here, I'm just going to say /root followed by alert.js. And that's it. I'm going to save this, Control S, and quit it, Control Q, and we are ready to go. So I'm going to go to my terminal. I'm going to run BetterCap using the exact same command that we've been using. So we're just giving it the interface as ETH0, and we're giving it our spoof file to automatically run the ARP spoofing attack, putting us in the middle of the connection. And as you can see, this is working with no errors, so everything is perfect. What I also want to do right now is run my HSTS hijack plugin. And as you know, all we have to do is just type HS and tab. This will autocomplete. I'm going to hit enter, and everything is running with no errors at all. So everything is perfect. And as you can see in here, it's saying that the payloads it's loading, the JavaScript payloads, are the keylogger. This is the default one that the file already was loading, and the one that we just specified, which is in root alert.js. So now, anytime our target loads any web page, whatever code we put in the alert.js should be injected in the loaded page, and it should get executed. The result of that should show us a simple message saying test JavaScript. So let's go to the target. And as usual, a good idea is just to remove the browsing data, just to make sure that nothing is cached. And I always like to first test with the simplest case and then move on to more complex scenarios. So first of all, I'm going to test it against a normal HTTP page so that there is nothing to bypass, no encryption whatsoever. So we're just going to go to vulnweb.com. And perfect, as you can see, we have an alert message in here telling us JavaScript test. So basically this means the JavaScript code in my alert.js file got injected into this page. So now that we've verified it works against normal HTTP pages, let's go ahead and test it against a page that uses HTTPS, such as stackoverflow.com. Perfect, it's working as expected. Another example would be linkedin.com. Keep in mind, these websites use HTTPS, and as you can see, we're able to load them with no HTTPS in here, so over HTTP only. So even if you log in right here, you'll be able to get the username and the password as shown before. Finally, let's go and test it against a HSTS website using the partial HSTS bypass method that I showed you. So for that to work, we'll need to go to Google first of all, and we need to go to a Google domain that does not use HSTS, similar to google.ie. This is actually the local Google website for Ireland. And as you can see, the code works. This is fine. Google only uses HTTPS anyway. But let's look for Facebook. Now we know Facebook uses HSTS, and because HSTS is used, we should not be able to inject anything on the website because the browser will only load it over HTTPS. But using our partial bypass method, if I click on Facebook from here, as you can see, the code gets executed because what we're loading right now is facebook.corn, not facebook.com. And as you can see, we get a normal Facebook page again that looks identical. And if you log in, you'll be able to get the username and the password. So as you can see, this will work against HTTP and HTTPS pages, and even HSTS if the target searches for that website, not if they put the domain name in here. So if the target comes in and literally types facebook.com manually and hit enter, the browser will force the HTTPS connection, as you can see in here, because like I said, it has a preloaded list of websites that it can only load over HTTPS. And because the browser is establishing a HTTPS connection, the data will be encrypted, and therefore we won't be able to inject anything in it. In the previous lectures, we learned how to use BetterCap to do a number of cool things. But everything we did it through a text or a terminal interface. There is also a web interface or a graphical interface for BetterCap that we can use to do everything that I showed you so far. The reason why I started with the text interface, because first of all, I actually prefer using it and I use that instead of the graphical interface all the time. I think it's faster. You can use it to achieve your goal and launch the attacks much faster. It also requires less resources and less modules. Therefore, it's less likely to fail and it's less buggy. Not only that, but by learning how to use the text interface, I also showed you how to manually modify the caplets and the scripts, where they are stored, and how to use them properly without the need for an extra plugin, which is the plugin that runs the web interface. With that being said, some people still think the web interface is more user-friendly, and that's why I'm going to cover it in this lecture. So I'm going to start BetterCap by typing BetterCap, and I'm going to do -iface to select my interface, which is ETH0, and I'm not going to specify a caplet this time because I simply just want to start BetterCap on the interface that is connected to the target network. So we're going to hit enter, and that will run with no issues as usual. Now, if you're using the custom Kali image that I made for this course, then you can simply start the web interface by typing http-ui. But if you're using the original version of Kali, or if you're using BetterCap on a different distribution, then you're going to have to install the web interface. So you're going to have to do ui.update to install it. And then once it's installed, you can simply do http-ui. Now, like I said, because I am using the latest custom Kali that is made for this course, I can simply run it by typing http-ui without having to install anything. And if I hit enter, you'll see that it's going to run with no issues on this URL. So I'm going to copy this, and we're going to go and open it in my web browser. And perfect, as you can see, we get the login page for the web interface. So the default username is user and the default password is pass. I'm going to click on login to log in. And as you can see, we have a very simple and easy to use interface. There is no more commands that we have to run, even though we can run commands here through the command line. Right here, we have the event log. So this is similar to what you see in here in the terminal, but it's in a much nicer interface. You can use the search bar here to filter if you're looking for a specific log or for a specific event. And you can actually click any event type to mute it, so you won't see any of that event on screen. All of this is happening in here in the events menu. The next useful page would be the LAN page right here, which will show you all the devices connected to the network. So this is similar to when we used to do net.show. As you can see right now, we only have the router, which is at 10.0.2.1, and my current computer, which is 10.0.2.15. This is Kali. Now, as you know before, we had to start the net.recon and net.probe to discover all of the devices on the same network. So in here, instead of writing the commands, all you have to do is click on this play button to start the net.probe and click on this play button to start the net.recon. You'll get nice notifications in here. And as you can see, we managed to discover all of the connected devices. You can also see in here we have a nice tag to tell us that this is the gateway and a nice tag telling us that this is our computer. And the devices that we discovered are these two devices. And you can see this is my MS Edge device, the Windows machine that we have always been targeting. Again, because this is a very simple web interface, you won't have to type anything. You can click on this little arrow right here beside the machine, beside the IP. You can either scan this machine for ports or add it to your spoofing targets. So you won't have to set arpspoof.targets to this IP. All you have to do is literally click here and it's automatically added to the ARP spoof. Not only that, but we'll see a nice little window in here to configure our ARP spoofer. And remember, we used to set this option to true, the full duplex. So all I have to do now is just click here to check it. And to start the spoofer, all I have to do is click on start spoofing and done. Now we should be spoofing the target. As you can see, we also see a nice icon in here beside this IP to tell us that at the moment we are spoofing this IP, telling it that we are the gateway. So now if I go to my target and just do ARPA, you can see that the router's MAC address has changed to the MAC address of the Kali machine, which is this one. So that means that we are properly spoofing this device, telling it that we are the router, and we managed to become the man in the middle. Now, I've actually showed you how to do all of this before in details, so if you don't remember any of this or if any of this feels strange, then please go back and revise the lectures where I covered these things. Now, I also showed you how to bypass HTTPS and partially bypass HSTS using a caplet. Again, we have a nice menu here for caplets. And as you can see, we have all of the caplets currently available with BetterCap. And all you have to do is just click on the caplet that you want to run. And in my case, it's the HSTS hijack caplet. Also, if you remember, when we were modifying this caplet, we used to have to open the location where the caplets are installed and then open the caplet in a text editor and then modify its options. Whereas in here, you can literally modify any options you want within this menu. Click on the disk icon right here to save, and then click on play to run this caplet. And as you can see, you get nice notifications telling you that everything got executed as expected. And right now we can go ahead and test this. So if I go here and just clear the browsing data as usual, and then if I just go to a normal HTTPS page, such as stackoverflow.com, you'll see that this will load over HTTP. So we can log in and we should be able to get the username and password as I showed you before. And we can test the partial HSTS bypass. So if I go to google.ie and search for Facebook, click on the first result. And perfect, as you can see, it's loading over normal HTTP here again. So if I log in, the information will be captured by my sniffer. So as you can see, it is very easy to edit caplets and even run them through this web interface. You can also run all of the other plugins through the advanced menu in here. So for example, if you wanted to start the sniffer, all you have to do is just scroll down here looking for the sniffer. And we have it right here, net.sniff. If I click on that, as you can see on top, it's telling us it's not running. And right here, instead of running the commands, all you have to do is just click on the command that you want to run. Not only that, but if you wanted to modify any of the options, again, all you have to do is just type whatever you want to modify in here, click on the save in here, and then run the command that you want to run. So if I wanted to start the sniffer now, all I have to do is just click on net.sniff on, and this will start the sniffer for me. Now, the sniffer combined with the nice events that we can get in here makes it easier to filter through the data that we capture, but it's still not the best way to filter through the captured data. I will cover how to properly sniff data and filter it using Wireshark, which is the best tool for sniffing and filtering data. But again, this web interface right here provides a nicer way of interacting and using better cap. Now, I didn't show you how to use the Wi-Fi, the BLE, the HID, and the Poison menus because we actually did not use any of these modules previously, so I just wanted to focus on showing you how to do everything we've done so far using this interface. Like I said, it is easier to use, I agree, but once you get used to the terminal interface, it will be just as easy as this one. To me, it's more organized, it can be used to achieve my goals much quicker, it uses less resources, and it's faster. That's why I prefer using it over the web interface, and if it wasn't for showing you how to use the web interface, I wouldn't even install it. But at the end of the day, I wanted to show you both options, and obviously you're free to use whatever is easier for you. In this lecture, we're going to talk about a tool called Wireshark. Wireshark is a network protocol analyzer. It's not designed for hackers and it's not designed for hacking and spying on other people on the network. It's designed for network administrators so that they can see what's happening in their network and make sure that everything is working properly and that nobody's doing anything bad or doing anything suspicious on the network. The way that Wireshark works is it allows you to select an interface and then logs all the packets or all the traffic that flows through that interface. So you're selecting an interface, it could be a wireless card, it could be a wired card on your current computer, and then it'll start logging all the information that flow through that interface. It also has a really nice graphical interface that allow you to analyze this traffic. So it allows you to filter these packets based on the protocol using them, like HTTP, TCP, and all that. It also allows you to look for certain things. For example, if you're looking for cookies or if you're looking for posts or GET requests. And it also allows you to search through these packets. You can search through the information that's stored in the packets and find the things that you're looking for. It's a really big tool and you need a whole course for it. So in this course, we're actually going to use it in a few lectures, just covering the basics or the things that's related to us. So the main idea here is Wireshark is not a hacking tool. It only allows you to capture the traffic that flows through your own computer, through your own interface. I'm going to use it now and it's going to become more clear to you. So I'm just going to go to Kali and we're going to start Wireshark. You can run Wireshark from the command prompt, or you can just go on all applications and type Wireshark and it'll show up right here. I'm going to click that and that's going to load the program for me. This is just a normal error. Just ignore this error. And this is the main interface of Wireshark. So first of all, you can actually just go to the file and go to the open, and in here it'll allow you to open a file that you've already captured. So for example, if you captured packets using a different sniffer, using Aerodump or using Man in the Middle F or using T-Shark, which is the command prompt part of Wireshark. So if you captured packets using any of these programs and you stored it in a file, you can just come in here, open it, and start analyzing that file. This is really handy because sometimes you don't really want to analyze the traffic on the fly. So sometimes you just want to capture it. Sometimes you're capturing from small laptop, or you're capturing from your phone, and you're not even at home, you're in somewhere else doing your pen test, and then you go back home and then you want to analyze what you captured, then you can store that in a file and then just come here, go to the file, open the file that you want to analyze. So what I want to show you here is the idea that Wireshark is not a hacking tool. It's not going to capture things happening in another device. It will only capture things that flow through your own interface. So right here we can see that we have all the interfaces in my computer. So we can see that we have ETH0, we have any, which is just any, and we have all the other ones that some of them are created by VirtualBox. So the main one here is ETH0, which is the virtual interface connected to my NAT network. And you can see that there is no traffic flowing through this. So you can see that this is constant and nothing's happening. So what I'm going to do now is I'm just going to make this a little bit smaller. And I'm going to open my browser here. And I'm just going to go to a normal website. I'm just going to go to google.com. Now, as you can see right here, you can see the traffic in ETH0 is spiking up. So there was some traffic generated through ETH0. So if we're sniffing on this, we'll be able to capture these packets that were sent over ETH0. Now, what I'm going to do is I'm going to go to my Windows machine just to prove that point. And I'm going to browse the website here. And you'll see that ETH0 will not be affected. And the traffic that's generated on this Windows machine, which is in the same network as the Kali machine, it will not be captured by the Kali machine. So if I just go to Google again here, you'll see that nothing happened in ETH0. So there is no traffic flowing through this. It's still constant. And we can only capture packets that go through ETH0. So now you'll probably ask then why Wireshark is so useful. Why are we even talking about it if we can only see things that go through our own computer? Why are we talking about it? Well, we're talking about it because we've seen there is a large number of ways that you can become the man in the middle. We learned how to do this using ARP spoofing, and in future lectures, I'm going to show you how to do it by creating a fake access point. So when we are the man in the middle, if we start sniffing on the interface that's used to become the man in the middle, we'll be able to capture all the traffic generated by the people that we're targeting in our man in the middle attack. So if you started a fake access point, you can start sniffing on the interface that's broadcasting the signal, and you can capture all the packets sent or received to anyone who's connected to that fake access point. If you became the man in the middle using ARP spoofing, then just select the interface that you used when you launched your ARP spoofing attack. So for now, I'm going to become the man in the middle using ARP spoofing. You can use ARP spoof or bettercap as I showed you earlier, but I'm going to use bettercap using the exact same command that we used to do. So we're literally just doing bettercap, followed by the interface that is connected to my target network, which is ETH0, and I'm launching my caplet, the spoof caplet, so that it configures the ARP spoof module and runs it for me to put me in the middle of the connection. So I'm going to hit enter. And as you can see, it's working as expected. So right now I should be in the middle of the connection, intercepting anything the target Windows machine sends or receives. Now let's go to the Windows machine and see if I do anything here, if it's going to affect the traffic in ETH0. So we'll see if Wireshark will be able to capture traffic generated by this computer. So let's write anything here. I'm just going to Google, or I'm just going to go to a different website. I'm just going to go to Bing. And if we come back here, you'll see that we have traffic being generated here. And we can see that ETH0 is actually capturing whatever that's happening in a completely different device. This is happening because when we are the man in the middle, all the packets that's generated by the Windows device is actually being redirected to my own computer right here, to the Kali. And then Wireshark is sniffing that from the Kali machine. It's sniffing it from my own local machine. It's not sniffing it from the network. It's not sniffing it from the target computer. So again, if you're doing this with the fake access point, then just listen on the interface that you're broadcasting. If you're doing this with a real wireless network, if you're connected to your home wireless network using LAN 0, then you can just do this with LAN 0. But with ARP spoofing, you have to first redirect the traffic, then you can use Wireshark. Now, this is just to show you what Wireshark is and how it works, and I just wanted to stress the idea that Wireshark is not a hacking tool. It's only a program that allows you to log packets flowing through a certain interface and then analyze these packets. So in the next video, we'll see how we can sniff and analyze packets using Wireshark. In the previous video, we seen how we can launch Wireshark, and we said that we can actually just open a file that contains packets that we already captured, and we can start analyzing them using Wireshark. In this video, I want to start sniffing packets and then generate some traffic in my Windows machine, and then we'll see how we can analyze these packets using Wireshark. So I'm already the man in the middle. As I said, you first have to be the man in the middle to use Wireshark. And then the traffic that's generated in the Windows machine is actually flowing through ETH0, as we've seen in the previous video. So before I start capturing the packets, I want to go to the options, and I just want to show you what options we can set. So first, you can see all the interfaces that you have, and you can see the traffic generated on them. And you can see ETH0 is actually generating some traffic every now and then because it's actually coming from the Windows machine. So in here, you can select the interfaces that you want to start capturing on, and you can actually select more than one interface, and all you have to do is just hold the control and then click other interfaces that you want to listen on. For example, we can just click them like this. But for now, I actually only want to sniff on ETH0. Now, if we go on the output, you'll see that you have an option to store these packets somewhere. So again, if you only want to sniff and you don't want to analyze things, then you can just go on the browse and you can store the packets that you're gonna sniff somewhere, and then you can analyze them whenever you have the time at a different time. You can just open them with Wireshark like I showed you in the previous video. You can just go on File, Open, and then open the packets and start analyzing them. Now, I have ETH0 selected, and I'm just gonna click on Start. And that will start capturing packets. Anything that's going to flow through ETH0 will be captured, and it will be displayed in here. Anything. I mean, images, pictures, messages, cookies, anything that computer does on the internet will flow through ETH0 and therefore will be captured by Wireshark. So it's not like man in the middle life where it was only showing us the important information. Right here, you'll see anything, all the traffic that's generated. Now, I want to go and generate some traffic on the target computer so we can analyze it here. But before I do that, I'm going to go back to BetterCap. And I want to start my HSTS caplet so I can downgrade HTTPS to HTTP, because if everything goes over HTTP, we won't be able to see or read anything because, like I said, everything will be encrypted. So I'm going to hit enter. This will work as expected. We'll go back to Wireshark and let's go to the target computer. I'm going to go to google.ie and let's search for something. So for example, let's search for Z-Security. And keep in mind, everything is loading over HTTP in here. So that's why we'll be able to read and analyze everything that we're loading right here. Now, let's go back to Wireshark and see how we can filter this information and discover the websites visit by the target, see the requests and all that. So I'm going to click on the stop button to stop this. Now this is the main interface of Wireshark, and you can see that the first thing we have is each one record of this is a packet. Now you'll see here the columns. First of all, here is the number of the packet. So you have this one is number 1, number 2, number 3, number 4. In the time, you'll see the time when this packet was captured. So 0 is when we first started sniffing, and then the time increases as we go down, and it shows when these packets were captured, when they were sent basically. You can also see the source. So this is the device that the packet was sent from. And you can see that this one is not sent from our target. It's actually coming from the internet, from a server that has this IP, and it's going to our target computer, which is 10.20.14.206. You can see the protocol, so it's TCP for this one. You can see that it's ICMP in this one, and you can see that it's ARP for this. You can see the length, which is the size, and you can also see info about this packet. Now you can also notice that these packets have different colors. Usually green is TCP packets, dark blue is DNS packets, and if we go down, we should actually be able to find some of them. And you can see all of these are DNS packets. Light blue usually is UDP, but we don't have any UDP packets at the moment. And you can also see that we have some black packets, and these are TCP packets that had a problem, that had issues. Now I know what you're thinking. There are so many packets in here, and a lot of them might not be useful to you, depending on what you're trying to get. But don't worry about this. In the next lecture, I'm going to show you how to filter these packets to only display the relevant ones and then analyze them to extract the useful information. In this lecture, I want to spend more time with Wireshark showing you how to filter all of these packets to only display the useful packets, how to trace them, what do they mean, and how to display more information about each one of these packets. Now, what we did on the target computer so far, most of the traffic that we generated was HTTP traffic. So to get rid of all this information that's hard for us to read, we're just going to type in here in the filters, we're just going to type in HTTP. Hit enter. And as you can see now, that filtered all the packets to HTTP traffic only. So this is the traffic that was basically sent by the browser and is usually sent by web browsers. They always send traffic over HTTP or HTTPS. And since we're downgrading HTTPS to HTTP, you want to use the HTTP filter to see everything that a target person is doing on the browser, regardless of what they're doing, whether they're browsing websites, whether they're watching a video, whether they're looking at images, whatever they're looking, it will be loaded over HTTP. So, looking at the first record right here, we can see that this request is sent from this IP, which is the IP of my target, to an IP on the internet. So we can see that this is not a private IP, this is an IP on the internet. So it's sent to a server. And if we double click this record, we'll get much more information about the packet itself. So we have the information about the frame, which includes the size of the packet. It includes the interface that it was sent on, the time, and all that. In the Ethernet, we have information about the source MAC address and the destination MAC address. So where did this packet go from and where did it go to? Remember when I first spoke about packets and how they always travel from a source MAC to a destination MAC? So this information is all stored in here. In the Internet Protocol, we have information about the IPs. So in the Ethernet, we had information about the MAC addresses. In the Internet Protocol, we have information about the source IP and the destination IP for this particular packet. In the Transmission Protocol, we have information about the port. So we can see that this went from this source port to port 80. This is usually the default port used on web servers. So in most cases, whenever data is sent to a website, it will always be sent to port 80. But the most important part in here is the Hypertext Transfer Protocol, which is basically the data sent over HTTP. Clicking on this will give us information on whatever that has been sent over HTTP, and like I said, this would contain everything that was sent to and from a browser. So right here we can see that this particular packet sent a GET request to a website called google.ie. Now this is literally when we typed google.ie, we didn't search for anything, we didn't really do anything. You can also expand this to see more information about the actual request, and you can even see the HTTP header sent if you want to get more information about this particular request. Now, this whole method of getting information follows with all types of packets, so you can double click any packet you have and you'll be able to read the data sent within this packet. Now, you can also in here see an arrow, which basically means that this was a request, and the arrow back here marks that this was a response to this request right here. Now, moving down, you can also see requests for images. What you can also do is click on any of these packets. For example, again, back to this GET request, right click it and go to follow HTTP stream. And this will basically follow the stream that this request has caused all the way down to the response. So if I click it, you'll see the response for this particular request was this right here. You can see that this was a PNG, and literally the binary content of this PNG image is right here. So as you can see, we're literally getting the raw data in here. Now I'm going to close this and go back to what we had, which was HTTP. Now if we keep going down, you literally see everything that has been sent and received by the target. So for example, again in here, we can see this was a JavaScript file that was loaded by Google. Then in here, we can see another GET request, and this GET request was what we searched for Z security. So you can even see the search term in here. So let me double click this to show you in more details. Again, this automatically went to the hypertext protocol part. Like I said, this is the HTTP part, whatever that gets sent to the browser. And you can see that this was sent to google.com first of all, and the URI, so whatever went after google.com, was search, and what we were searching for was Z security, which is exactly what we typed in here. Again, in here, you can see the full URL with the search term. This is literally what the user gets in their URL bar in here. So as you can see, Wireshark literally shows everything that flows through the interface. In this lecture, I wanted to show you a quick overview on how we can filter data. And don't worry too much about this. We'll actually be using it more in the next lectures, and we'll see how we can easily use it to filter data and discover useful information. Now in this lecture, I want to show you how to use Wireshark to discover data sent through forms whenever someone fills up a form. And obviously this will allow us to get usernames and passwords if people log in to their accounts. So I'm already running BetterCap, so I'm already the man in the middle. And in Wireshark here, I'm just going to start a new capture. So I'm going to continue without saving this one. The filter is already set to HTTP, so it's only going to show me HTTP packets in here. And I'm going to go to a target website in here. So let's go to vulnweb.com. Now keep in mind, like I said, you have to be logging into a HTTP page, but that's fine because we already learned how to bypass HTTPS and even partially bypass HSTS. So I'm going to be logging into a website that just uses HTTP here because it's just simpler, and we've already learned how to bypass HTTPS and HSTS, so there's no point of repeating that. We're logging in with a username that is set to admin. I'm going to set the password to 123ABC. I'm going to click on login, and this should have been captured by Wireshark. Now let's go ahead and actually try this with a website that uses HTTPS. So let's go to stackoverflow.com. Again, as you can see, as long as the website gets downgraded to normal HTTP, then we'll be able to capture the data sent to and from this website. So we're just going to log in, put the username, we'll put it to zaid@zsecurity.org, and then we're going to put the password. So we'll just do 123ABC. And let's go back to Wireshark and see how we can discover the username and the password. So first of all, I'm going to stop the capture. And what we want to look for is post requests. So you see in here, this request right here was post, for example, and here it was get. Now forms are usually sent over post, especially login forms. So if you're looking for login information, you want to look for post in here. So going down, we can see we have a post request in here. Now I'm going to click here to actually show less information so it's easier for us to see. So we can see this post was sent to Google. We're not interested in that. We're looking for stuff that was sent to VulnWeb. So I'm going to keep going. We can see we have a post request here to a login page. So this is definitely interesting. Now if we look down, let me just make this smaller. So if we look down here and look at the HTML form data, you can see that we have a username here submitted to test.html5.vulnweb.com. The username is admin and the password is 123abc. Now if we scroll down again looking for post requests, you can see we have a post request for a page called users login. So again, very, very interesting. If we click on this, you'll see, if we scroll down, you'll see we have the email zaid@zsecurity.org and the password 123.123abc. Again, this just goes to show you that with Wireshark, you'll be able to capture everything. Now, this can actually be very, very useful because I noticed that BetterCap is great at sniffing passwords and it pretty much gets you the passwords all the time. But in the odd cases, sometimes it was failing to filter the username and the password for me. So with Wireshark, you'll actually be able to get everything that passes through your interface. So what you could actually do is you can just go to your caplet that we always use, the spoof caplet, this one right here, open it with the text editor. And as you know, in this caplet, we turn on our sniffer in here. So we set the sniff.local to true, and then we turn it on. But before turning it on, you can actually set the net.sniff.output to a location for a file that will contain everything that BetterCap captures. So you won't actually have to start Wireshark while BetterCap is working. You can just in here specify a place. So for example, let's say root capture file.cap. And then when you run your spoof caplet, it'll turn on the probe, turn on the recon, run your spoofing attack, putting you in the middle of the connection. It'll run the sniffer as well, and it'll store everything that BetterCap captures in a capture file. Then all you'll have to do is come here, go to File, Open, and open the file that you captured and analyze it as I'm doing right now. So this can be very, very useful also if you don't have a lot of resources on your computer, or if you had a small laptop or even a phone and you capture data with it. Store everything in a capture file and then just open it in here in Wireshark and analyze it. Now finally, before I finish this lecture, because all we're talking about right now is filtering data, a really, really useful feature when filtering data is the Control F feature, the find. So you can just press Control F from your keyboard. This will open this bar right here, the search bar, which you can use to find anything within the captured packets. So first of all, I'm going to set the search to search within the packet details. I'm going to keep this to narrow and wide. In here, I'm going to set this to string so that it looks for normal text. And for example, let's say I'm looking for logins that a person named Zaid has attempted. All I have to do is just type Zaid. And if I hit enter, and as you can see, it's taking us to the login attempt when I logged in to Stack Overflow. Or let's say you're looking for login attempts by a person named admin or for a user named admin. Again, if I hit enter, it's going to take me to the first time an occurrence of the word admin happened, which is in here. It doesn't really contain any useful information, but I can just click on find to find the next packet that contained the word admin. Again, this packet doesn't really contain anything useful. We can go next. We'll actually have to go to the end of the file and go up because that was the first thing that we logged in. So I'm just going to keep clicking on next. And right here we have the post request for the admin. And if we go down again, as you can see, we have the username as admin and the password as 123ABC. So this feature can be very, very useful to help you find what you're looking for. Whether you're looking for a specific login name, whether you're looking for a specific tag, a specific file, and so on. Now, from the previous lectures, we know once we connect to a network, it's game over. Because once connected, we can run an ARP spoofing attack to redirect the flow of packets so that they go through our computer. This allows us to become the man in the middle, and once we're the man in the middle, we can run so many dangerous and effective attacks. So we can spy on all the users, steal their passwords, redirect them to different websites, and this is all just a small taste of what you can do. You'll actually see us build on this in the client-side attacks section, where we're going to completely hack into computers connected to the same network as us. And if you go and do my advanced network hacking course, then you'll see more advanced attacks that will allow us to do so many cool stuff on the network. Again, all of this is possible because once we connect, we can run ARP spoofing and become the man in the middle. Now in this section, I actually want to show you another method that will allow us to become the man in the middle. And once we're the man in the middle, we'll be able to run all of the attacks that you've seen so far and all of the other man in the middle attacks that you'll learn in the future. So let's go back to the first diagram that we learned in this course. When we were talking about how networks work in general, we said the only device that has access to the internet is the access point, and whenever a client wants to access something, they send the request to the access point goes to the internet, gets the response, and send it back to the client. Now, what if we replace this access point with our hacker computer? So what if we can use our machine to create a Wi-Fi network that actually has internet access, so people will actually try to come in and connect to our network to access the internet, and then when they connect to our network, by default, we will be the man in the middle because we are the router. So we won't really need to exploit anything. We are automatically the man in the middle, and the clients will automatically send us any requests because they want to access the internet, and we will see these requests, obviously, go to the internet, get them what they want, and give it back to them. This way, we'll be able to launch all of the attacks that I showed you previously without the need to exploit the ARP protocol, so without the need to run ARP spoofing. All we'll have to do once our network is running and we have clients connected, we can just start sniffing using Wireshark or BetterCap. So, for this to work, you need a computer, and we already have our hacker computer with Kali Linux. You also need internet access, and you need a wireless device that's going to broadcast the Wi-Fi signal and tell all the neighboring devices that I am a network, you can come in and connect to me. So, you will need, first of all, an interface that has internet connection. This interface, it can be a Wi-Fi interface connected to the internet, it could be an Ethernet interface connected to an Ethernet network, it could be a 3G or a 4G dongle, and it even can be a virtual interface, and this is what I'm actually going to do. It's going to be my ETH0, the virtual interface that is connected to my NAT network. So this can be any network device as long as it has internet access. The next interface that you will need, like I said, it's gonna have to be a Wi-Fi interface because it needs to be able to broadcast the signal for the network. And you can't use any Wi-Fi interface. This interface needs to be able to act as an access point. So it needs to be capable of acting like a proper access point, like a router. Now, all of the Wi-Fi adapters that I recommend support this mode, and I've already included a video in the resources before when I first spoke about wireless adapters, but I'm also going to include this video in the resources of this lecture. So if you're going to buy one, or if you're not sure how to pick the right one, then check out this video. It should be helpful for you. So once we have this set up properly, we can use our computer to start an access point, and it's going to act exactly like a router. So people will be able to see the network when they look for Wi-Fi networks. They'll be able to connect to it and get internet connection. But when they connect, they will have to send us all of their requests because we are the router, we are the access point. So by default, we will be the man in the middle. Therefore, you'll be able to execute all man-in-the-middle attacks that you learned so far and any other man-in-the-middle attacks that you will learn in the future. So basically, ARP spoofing is one method of becoming the man in the middle, and what I'm going to show you right now is another method of becoming the man in the middle. Now, you can see that in order to use our computer as an access point, we need a number of components to be configured properly. So first of all, we need our wireless interface to broadcast the signal as if it's a real network. This will allow other clients to connect to it, but that's not the end of the road. The wireless interface needs to know when these clients are requesting websites. It needs to be able to forward these requests to the other interface that is connected to the internet. Then again, it will need to be able to know when the responses come back and forward all of this to the right client. Now you can configure all of these things manually, and I actually cover this in my advanced network hacking course, and I cover a lot of advanced things that you can do with the fake access point, like launching an evil twin attack, hacking into WPA2 Enterprise, and so on. But this would take at least 30 lectures, and this is not a network hacking course. This is a general ethical hacking course. Therefore, that would be out of the scope of this lecture. If you're interested in learning how to do this manually and how to run advanced attacks using the fake access point, then check out my advanced network hacking course in the bonus lecture, the last lecture of this course. For now, for this course, I'm going to show you a great way of quickly creating a fake access point that will allow us to become the man in the middle, similar to what's shown in this diagram. Now, before doing anything, I want to show you the network settings of my Kali machine. So I'm going to select it here. I'm going to go to Settings, Network, and as you can see, it's set to use a NAT network. So now if I go to my Kali machine and do ifconfig, we'll see we have an interface called ETH0. This interface is a virtual interface created by VirtualBox because we set this machine to use a NAT network. You can also see that this interface has an IP address, which means that it is properly connected to this NAT network, and it will provide the Kali machine with internet access as long as my host machine right here has internet access. So now on my Kali, if I go and let's say if I just go to bing.com on my browser, you'll see that I can successfully go to the website because Kali is connected to the internet through this virtual interface that is called ETH0. Now, if we go back to our diagram that shows what we need to create an access point, you can see that we need an interface that is connected to the internet. We don't care what type of interface this is, as long as this interface has internet access. So in our example, we're going to be using ETH0 to provide our fake access point with internet access. The other interface that we need, we said that this needs to be a wireless adapter that is able to act as an access point. Again, if I go back to the result of my ifconfig, you can see I already have a wireless adapter connected to this computer. It's called LAN 0. Keep in mind that this is in managed mode. It's not in monitor mode. And it is not connected to anything. So you can see it does not have an IP address. This is very, very important. It needs to be, first of all, in managed mode, and second, not connected to any network. So even if we go at the network manager in here, you can see we have wired connected. This is my ETH0, and Wi-Fi not connected. Once we have everything configured properly, we can go ahead and start the fake access point. The program we'll use is called Wi-Fi Hotspot. It's pre-installed in the custom Kali Linux that we made for this course. So all you have to do is simply click on Show Applications in here and type Wi-Fi, and you'll have the application in here. Now, if you're using the original Kali, I'm going to include a link in the resources that you can use to download and install this tool. But right now we can simply click on it right here to start it. And as you can see, it has a really nice graphical user interface that is self-explanatory, but I'm just going to walk you through it real quick. You can see, first of all, it's asking us for the SSID. This is the name of the network that the clients will see when they look for Wi-Fi networks around them. So I'm going to keep this as internet. Next, it's asking us if we want to have a password on this network. So I checked the open box, which basically means this will be an open network with no password, because it makes more sense in our scenario so that we can attract more people and spy on their traffic. If in your scenario it makes more sense to have a password on the network, then you can uncheck this box and put the password in here. So I'm going to check it back in because I want it to be open. And next, it's asking us for the Wi-Fi interface. This is the interface that will be broadcasting the signal. So this will be this interface right here. And in our case, this is my wireless adapter, and it's called LAN 0, as we seen earlier. And next, it's asking us for the internet interface. This is the interface that will provide the fake access point with internet access. Again, going back to the diagram, this will be the interface in here. And we said it doesn't matter what type of interface. It could be a wireless card or a wired. It doesn't really matter. In my case, I'm actually getting my internet access from ETH0. So it's already selected correctly. And that is my virtual interface that is connected to my virtual NAT network. Now, before starting the access point, let's click on the advanced just to have a look on the other options that we can set. So you can see you can select the frequency band. You can set it to auto or 5 gigahertz. You can set this network to be hidden. You can use a pre-shared key. You could set the MAC address of the network. You could configure it to not use any virtual interfaces. This might be useful to try if it's failing to start, but we're going to keep it the way it is. You can specify the channel that you want the network to broadcast on. You can check this box to use MAC filtering and then specify the MAC addresses that you want to allow to connect to this network in here in this box, so that only the specified MAC addresses in here are allowed to connect to this network. Again, we don't want to do this in here. And you can also select the standard in here for the N and the AC. We're just going to keep everything on the default settings in here. We really don't need to change anything in our specific scenario, but I just wanted to go through it real quick just so you have an idea in case any of these options make sense in a future scenario that you'll find yourself in the future. So the main things that you'll really need to set when you're starting a fake access point is the name, the Wi-Fi interface, and the internet interface. And once you're ready, click on Create Hotspot. And perfect, now it's running, as you can see, and it's giving us the process ID that it's running through, just in case it freezes and you need to kill it through the terminal. But now we have a fake access point that looks like a real Wi-Fi network with internet access that is broadcasting within our range, and the name of this wireless access point is Internet. So let's go to the Windows machine and see if this access point is working as expected. So right here I have a Windows machine. It's another virtual machine, but I have another wireless adapter connected to this machine. Do not test this from your host machine because the fake access point is getting its internet access from the host machine through the NAT network. So if you test this network from the host machine, the network will not work. So either test it from another virtual machine with another wireless adapter, or if you don't have another wireless adapter, then you can test it from your phone or from another laptop or any other computer within range. But do not ever test it from the host machine. So right here, I'm going to search for networks to connect to. And as you can see, I have a network called Internet. It does not use a password, so I'm just going to connect to it. As you can see, I'm connected now, and I'm going to open Firefox just to check if I have internet connection. So I'm going to go to bing.com. And as you can see, bing.com is loading, so now I actually have internet access. So now anything I do on this computer will have to be sent to the access point. If I want to access any websites, if I enter any passwords and usernames, everything is gonna go to the access point. And the access point is the hacker machine, so the hacker machine is already the man in the middle. So now you're at the same position that you would be after running an ARP spoofing attack. So you can go ahead and use Wireshark to sniff packets and analyze them, or you can go and use Bettercap exactly as I showed you before. The only thing that you need to keep in mind when using Wireshark or any other tool, you need to set the interface to the interface that is broadcasting the signal. So this is the interface that you set in the PHY option, not in the upstream. So in my case right now, this would be LAN 0, not ETH0. Once you're done and you want to stop this access point from running, don't click on the X. Make sure you click on stop first to stop it properly. And then you can exit the program and continue whatever you want to do.